In this video, I'll show you the pizza oven that I designed and built, and I'll give you an overview how I used Autodesk CFD analysis to simulate the thermal flow from the heating elements into the chamber and out through the chimney. I use that to predict how much power I'll need to drive into the oven to get the right temperature and where is the low temperature points. So you can see here I took the cover off. The cover is designed to protect it from rain and to create thermal insulation for the heat to not escape to the free air by convection. You can see the build itself here. This is again without the cover. And our goal is to get to something like this that shows the different temperatures and shows the airflow. This is over time, just shows you how the temperature increases inside the oven. So let's start from the design itself. As you can see, the full design is pretty complicated. It has multiple parts, multiple materials, and it's just too much to run thermal simulation on. It'll take a long time and it'll take me forever to define all the different materials where most of them make no difference in the thermal performance. So what I did, I took that original design and I took all the measurements and built a simplified model that is not made out of discrete bricks. It's made out of one solid piece, so it'll be much easier to run all the calculation. And by easier, I mean for the computer. It does have the thermal insulation on the outside, and it has the pizza stone on the bottom and the concrete base. And obviously the two heating elements from the inside. And that's really all I need. So it's just important to make sure that I have all the correct gaps, and I'll explain more in the pizza oven video, but there is a gap under the pizza stone and you can see it also here, the same crosscut. You can see that it's pretty similar. All those gaps between the fire breaks are obviously filled with mortar, so there is no point in having them in the simulation. So let's start. So first thing I did is loading the model and then creating a box around it. Now this box defines how much calculation around the actual object the software will do. If you define it too big, it'll just take longer to run it. And if you design it too small, then it will not be accurate. So you can see here, I'm defining it to have enough space in the surrounding of the pizza oven where the air will actually have to flow. And now when I'm done with that, I'll start defining the different materials in the pizza oven. So first thing, I designed the two heating elements which are made out of stainless steel. So I'll select them and then I'll define them as solid and as stainless steel. The next thing I have to define is the environment, and the environment here is air. And I'll select the volume that we defined before that surrounds the pizza oven, and I'll define it as air. Now make sure it needs to be fluid, air, and then in set it needs to be defined as variable. This is important because this air moves. The next thing I'll do, I'll define the rest of the materials. And you can see here, if you go to unsigned, you can see what's missing. And you can see the volume here. This is the small volume of air between the pizza stone and the base. I'll just define it as air, and it does not need to be variable. Next, I'm going to go to the full construction, but before that, I'll just make this box disappear by just pressing it and pressing the hide button. This will let me see the actual pizza oven. And all three materials I'll define the same as concrete. They're not really concrete, but concrete is close enough to what I need. I can go more accurate, but I did not feel there's a need with this simulation. So you can see here, solid concrete, pretty straightforward. So now you can see all the materials are assigned. And the next thing I need to do is define my boundary conditions. And the first one will be to define the heat source. So I'll go to boundary conditions. I'll select the heating element, and I like doing it one at a time. I'll first select the right one. I'll click it, and then I'll select BTU hour and put 20,000. I actually put 20,001 just so I can know which one is the right one and which one is the left one. The other one is the same. I'm just going to select it and then go into the definition, put BTU hour, and then put 20,002. So the 2 doesn't really matter. It's less than 1%. No one cares. So the next, after we define that, so now we have a heat source. What I'm going to do now is bring back the box. And this is the box of air that everything is captured in. And I'll define the conditions in that box. So we know air goes from bottom to top. So we'll define the top and define the bottom. So I've selected them, and then I put pressure, and pressure stays 0. That's all it is, pretty straightforward. And you can see the software marked those two sides as assigned. The next thing I need to do is define the initial temperature. And for that, I only need to do the bottom. And I'll define it as 25 degrees Celsius. This is more or less room temperature, and it's good enough for what I need. So you can see here I have 2 assigns for the bottom and 1 for the top. So now I can remove the surrounding box again so I can see the actual structure. And you can even see, if you look closely, you can see that the heating element is marked. That means that it was also assigned the boundary condition. So now I just decided to remove the coordinates. So you go to View, Axis, and just click them off. That'll just make it easier to see after in the results. And then we need to mesh it. So go to Mesh, go to Automatic, and that's it. Nothing really that you need to do. The software does most of it. And then we'll press the Solve button. And now it's important. As you can see, our Y is pointing up, but gravity is down. So no gravity nor convection. So Y needs to be -1 because gravity is down. So we'll define that, and then we'll have it run. Now it does take some time. First it creates the mesh, then it starts simulating. So this is a good opportunity to get coffee or lunch, depends what computer you have. It will keep working, and at some point will spit up the result. And you can see when it's ready, it will give you something that looks like that. And I'll cover the results in the next video. I'll leave all the links in the description below. Please like and subscribe. And if you have any questions, feel free. Thank you.